Hello and welcome. Today we'll be going through the OptiAssist for Abaqus. This is tutorial 6. This is the sizing optimization considering plies symmetry pairs. In this example, the optimization is going to demonstrate the capabilities of defining a ply symmetry link between the plies and its sizing optimization. This will include a symmetrical laminate, which will prove in the CSV file reduced from the optimization. If we take a look at the initial displacement, we can see a displacement at the center of the hood at about 11 millimeters. The aim of the optimization will be to reduce this with optimized laminates through defining ply symmetry links. The first thing we're going to do is go over to OptiAssist and open up the tutorial6.imp file. Once the file has been loaded in, the first thing we are going to do is create a new thickness set data. We will name this one all plies with a minimum of 0 and a maximum of 20. We will then select all plies by clicking Control A, except for the core, so holding down Control, click that to deselect, and then with the new thickness set data selected, click Assign Thickness Set. Once you have done that, we are going to click Next. Under the Ply Linking tab, the first thing we are going to do is set up the Auto Define Symmetry function, with the left side of the body panel being paired with its right side component. In the master box, we will put LH for left hand, and in the slave field, RH. Clicking Auto Define Symmetry will then automatically pair the left hand sides with the right hand sides. Once you've done that, we can click Next. And under the Goal tab, no further changes to the objective are needed, so again we click Next. For the constraints, we will set up two different types of constraints. The first one will be a displacement, which we'll name disp for short, with an upper bound of 8 mil. After you've done that, we will then change the displacement constraint from node to node set using the placement set. We'll click Create and then repeat the process, but for failure index. This time naming it Findex for short. Keep the step as all, and the upper bound will be set to 0.7. Set the failure measure to SIWU, with it applying to all designed. We'll click Create, and then Next. Once you are happy with the setup solution type, we'll click Submit. Once your optimization has finished running, if you go back to your post processor, in this case Abaqus CAE, and open up your new optimized file, the tutorial6 OPT, you'll be able to find the new optimized model, where if we look at the same magnitude, it has now been significantly reduced at the maximum, from 11 to 8.9 millimeters. If we take a look at the laminates, we can see a perfectly symmetrical result in the number of plies that have been added on the left hand side and right hand side. To further prove this, if we go over to the CSV file created from the optimization, the ply fact map 0, we can see from the data that's been produced that on the left hand side and the right hand side, the number of plies that have been added for the optimization has been done symmetrically. This concludes the tutorial.